soon as you have double bonds in there, it becomes an unsaturated. Why? Because the double bond takes the place of where two hydrogens could go, right? And the one reaction we're going to learn about for alkenes basically is related to the hydrogenation of a bond. The only thing I want to talk about today is just the naming for alkanes, right? So I'll skip ahead. I'll go over all of the aromatic compounds and everything on Thursday before the quiz. The prefixes for alkenes are the same as for alkanes, right? So those prefixes, meth, eth, prop, all of those don't go away ever. So they're the same for alkanes and alkenes. And the only difference when we have a double bond is the suffix, is we replace ane with ene. Right, so ane turns to ene. So if you have cyclohexene, now that means there's a double bond in there. If you have hexene, that means there's a double bond in there. Pentene, there's a double bond in there. And so when we are numbering an alkene chain, the same way we try to keep the substituent groups on the lowest possible number, for alkenes, we always want the double bond on the lowest possible number. Is the lowest possible number on the main or parent chain. And then how do you guys think we're going to specify the place of the double bond? Yep, we're just going to put a number and a dash before the name of the parent chain now. So it's always going to be the number where the double bond starts, right? So specify the places when there's more than three carbon atoms, right? If you have 3 carbon atoms, there's only one spot the double bond can be in. As soon as you have 4 carbon atoms, then the double bond can change places. So this is with a number and dash. With a number and a dash, that's how you indicate. And it goes before the parent chain. Before parent chain. Hello?
All of you, is this Chem 3?
Yeah.
I have something for Ann Rivera. Hi. This is from the financial aid office. Sorry.
Oh, you're good. Damn, she yelled at me. I should have paused the video for that. I was like, there's not that many people in here. I gotta yell. Okay, so here's an example. We have this structure. This is a hybrid between a condensed and structural formula. So first draw the carbon skeleton for this, and then we'll name the structure. And the reason I draw the carbon skeleton first is because I feel like it's a little easier to name starting from the carbon skeleton. So how many carbons are in the longest chain here once the screen stops flickering? 1, 2, 3, 4, 5, right? And if we counted down or up, then it wouldn't matter. So there's 5 in the longest carbon chain, so that means the prefix is going to be what for this molecule? Pent, right? So it'll be 1, 2, 3, 4, 5. On the 4th carbon, what kind of group do we have attached to that? Methyl, right? And then what about between the 2nd and 3rd carbon? What do we have there? A double bond. And on a carbon skeleton, we indicate a double bond just by drawing another line between the two. Right, so that means there's a double bond between 2 and 3. It does not mean that there is an extra carbon atom here. It means that this is just a double bond between this atom and that atom. This is 1, 2, 3, 4, 5. Right? And we number it this way because it puts the double bond on the lowest possible number. Sorry, that was 3, 4, 5. And on the 4th carbon, like we said, we have a methyl group there. So the way we're going to name this is here's our methyl group. Here is our double bond. We start with the groups still because the double bond is indicated in the parent chain. So we start with the group, and the group's on which carbon again? 4. So we put 4, and it's 4 what? Methyl. And now we need to indicate where the double bond is. And the double bond starts on which carbon? 2. So it becomes -2. And then the length of the parent chain is how long? 5. So it's pent. And then it's, what's the suffix for this molecule? -ene, right? Because it's a double bond now. Right, so this tells us that we have a double bond. Pent tells us there's 5 carbons in parent chain. 2 tells us the location of the double bond. And then this tells us methyl group on the 4th carbon. Right, so it's identical to what we do with alkanes, except now we just need to specify where the double bond is and change the suffix because we don't have an alkane anymore, we have an alkene. So alkenes are a class of hydrocarbons that have double bonds in them.
You start numbering with the double bond.
We start numbering from left to right here because that puts the double bond carbon on the lowest possible number. So the alkene, and it gets pretty complicated because once you start mixing them, the priority changes, but alkenes in general are going to have a higher priority than most other functional groups we deal with. So we're always going to put the alkene on the lowest possible number. When you're naming it, you always put the groups in alphabetical order, right? So because the double bond, it doesn't change, it's not treated like a group on the molecule. The double bond is treated as part of the parent chain. So that's why the double bond is like, it's not the group names that change, it's the parent name that changes because now we have a double bond in the parent chain. So this is where the, kind of difference happens between alkanes and alkenes. This would be the same if it was an alkane or an alkene. We could have a lot of different groups here, and no matter what carbon they're on, we would still put them in alphabetical order.